All right, good morning, everybody. I would like to start off by kind of asking if one of you could confirm or put maybe thumbs up if you can hear me just fine or something. Okay, great. So we can start, I suppose. We're still hoping people have a wonderful long weekend, I guess, which is good. So we're going to continue our discussion of we'll continue off with our discussion of understanding operating systems, which is lecture series number 2. And I believe the last time we met, we kind of had a discussion which was really focused on the, I believe we're looking at the 2 primary roles of the quote-unquote operating system software, right? So we realized that fundamentally it operates as a resource manager, and then also, in addition to it operating as a resource manager, it operates as an extended machine or a virtual machine, ideally. Okay. Importantly, we then segued into our discussion of the core functions of a quote-unquote operating system software. We realized that there are ideally 5 core functions. I mean, it could be other things that you can throw in here, right? You know, like for instance, it provides you with an interface. If you want, you can throw in that as an extra core function as well, right? The fact that it provides you with an interface to this so-called computer system idea, right? So anyways, we discovered that there are 5 core functions associated with an operating system idea. Okay. So there's process management. There's memory management. There's input-output device management. Okay. There's file management, and then there's things like protection and security. And we discovered that in terms of process management, generally when when you're running a program, when you execute a program, it takes a certain predefined path, right? This is how software computers are designed, is it? What typically happens when you execute a program is the operating system is going to fetch it from secondary storage. So it fetches it on disk, okay, the instructions associated with that program, and then it loads it into primary memory called RAM, is it? And then from there, the instructions associated with the program are actually fetched and executed on the CPU. It's one instruction at a time, is it? So you have like your computer program, which is associated with a series of instructions. Once it's loaded into RAM, the CPU then fetches instructions one at a time. And you notice really that the interesting thing about how we're describing all of this, or how all of this was described to us, is the really gory details of what actually happens were abstracted away from us, right? So during your discussion of, I don't know if it was computer architecture, I think it must have been computer architecture, or we're looking at how instructions are executed, there was little mention of the fact that a program, ideally, a modern day program actually is multi-threaded, is it? So, a program will be associated with the program would be associated with processes, right? So I can in this particular case, I have a whole range of programs running on my computer right now. Is it? I can count them. How many processes? 430 processes, right? If I try to check programs that are associated with Chrome, because I have instances of Chrome, 2, 4, 6, 7 of them here. I notice that there's about 103 processes, ideally. But it turns out 103 processes, and I can check these processes, right? These things here. I don't know if you can see here, right? So there's this process here. It actually even shows you that I executed a program on May 20th, right? This is good, is it? It's telling me that this kind of also tells me how long some of these programs have been running. So for the last 6 days, some of these programs have been running, right? Now, what you have here at the beginning here is what's called the process ID, right? But it turns out that the process itself, we don't really see this as process ID here, but I'm just going to do it like this here. What you have at the very beginning here is a process ID, right? And then this is a parent process ID or something like that, right? This is the start time of the program itself. Now, what's particularly interesting here is if I get the process itself, one of the processes here is the one I just got is this, is it? It tells me that, I don't know why it's called crash pad here, but I'm going to check for something else here, try and see if I can find a more recent process like this. Copy it. If I check it, right, if I check a single process by feeding it a process ID, I see here that there's a program called Chrome here. Now, it turns out that when I have this, I can, so it's Chrome, right? Including the path, exactly where this Chrome binary is. So in fact, if I attempt to do a file of this here, it tells me that there's this file, it's an executable file, right? So there's literally a file in opt/google/chrome/Chrome. There's a Chrome binary. So in other words, if I attempt to go into this directory, I will find the Chrome binary right in here. In here, there's a file called Chrome. Where is it? It's in here. And this file is an executable file, is it? This is a program itself, right? 262 megabytes. If I check, this is an executable file, right? If this is making sense here. But what I wanted to kind of mention here is that if I do this here, I'm checking for this process, right? What I can do is I can check for the threads, right? The threads associated with this file. So you notice that this single process here is associated with execution units. So this is where your discussion in 2101 or something, in your discussion with 2101, you are told that modern day applications, software applications are multi-threaded. Okay, and this should make sense, is it? Because you see, when you have Chrome, right, an application like Chrome, there's a lot happening. There's a lot that you can do with Chrome. In my case, right, I have 1, 2, 3, 4, 5, 6, 7, right? 7 windows associated with Chrome, right? So in other words, I've executed, more or less like executed Chrome 7 times. I'm going to start and then I've said open Chrome, open Chrome, open Chrome. I do this a lot myself. I don't explicitly do this. Sometimes I will use my different Chrome profiles, is it? The different profiles for different accounts. So what I'll do is if I want to access a different profile, if I want to use Chrome using a different profile, I'll just use this feature in Chrome, right? Because I'm already logged on to these different profiles, and clicking on a profile spawns like a new window. But the way an application like Chrome would work is it works in such a way that typically, and I'll pause here and show you something as well. This is showing me, these are threads associated with just a single process linked to Chrome, right? But if I come here and I say, I just want to check all processes linked to Chrome. Remember, I counted them, is it? 134, right? So it's more or less like there are 134 different processes associated with Chrome. And I mean, you can pretty much do this here by, you can check the process IDs associated with this if you want to, right? Right? All of these processes here that you're seeing here, each one of these is associated with Chrome. And for each one of these, there are different threads associated. Now, the way Chrome works is it works in such a way that typically when you open a new tab or something, it's like a new process that is spawned, right? So right now, observe, right now I have 137 well, it's not like directly like it's one process per tab, but I'm just giving an example. Right now I have 137 processes, right? I'm going to count them again here, 137. If I just suddenly come here, right, and open a new tab, and I tell, I tell Chrome to say, I want to navigate to the UNZA website, right? So go to unza.zm or something, right? So ideally, what we expect is we expect Chrome to spawn off an additional process, right? A new process, ideally. Now, I would have to refresh my mind to try and find out exactly how Chrome operates, but this gives you an idea. It's not really like I'm saying this is exactly what happens or something. But if I come here and I count now, instead of 137, I have 139, so slightly more, right? So typically, the way these programs will work is like for Chrome, each tab is typically associated with one or more processes. But we know that Chrome is actually even much more complex than that, right? Why? Well, because Chrome has extensions, right? You can extend Chrome. So in other words, if I spawn off an extension, if I activate an extension like my Google Meet attendance extension right now, if I open it up here to just see attendance for today's lecture, the one that's happening right now, literally that extension is associated with a process or processes, right? So this is the one that is in progress, right? If I count now, I'm going to have slightly more. I don't know why it's less here. I don't know. But it's supposed to be slightly more, ideally, right? So the idea here is the way Chrome works is it's so complex such that it's multi-threaded, and usually it's designed in such a way that different sort of activities that take place here are associated with different processes. Okay. So anyway, so we discussed this notion that the operating system acts as a process, so it's there to manage all of these different processes because there is a whole range of processes, right? Chrome alone has 140 processes, but right now my computer has 436 processes that are running. In fact, I can even visualize them. Yes, I don't know if I have HTOP here. As a whole range of processes that are running. 276 processes currently running, right? How many threads? THR is here. 2,499 threads, ideally, right? 158 are kernel threads. 8 processes are currently running. So it's going to give you an idea of what sort of role the operating system performs insofar as process management is concerned, right? And I think what is also worth mentioning here, because remember when you're managing processes here, you're managing processes such that you ensure that resources are being equitably shared amongst the different processes. And in terms of resources here, observe, I have a finite amount of processing power that I have access to, or my computer has a finite amount of processing power, right? So in this particular case, I have 8 CPUs, is it? CPU code 0, 1, 2, 3, 4, 5, 6, 7, so 8 of them, right? And showcasing the percentage usage here, right? So at any given point in time, you notice that the usage kind of like changes, right? It's like snapshot is changing, but also at the same time, if you look at this thing here called, because these resources as they relate to processors, is it? For each process, you notice that the process will have access to CPU time, for instance, right? Memory and stuff like that. And every time you get a snapshot, the picture changes. So the operating system behind the scenes is actually making sure that these resources are being equally assigned to the different sort of processes that are available here or something like that. I don't know if that's making sense here. So we had a discussion of that. Once we get to lecture series number 3, I think it is, we will look at the 5 core states associated with a process, right? Because a process, once created, can find itself in 5 different states. So more on that later on. our interest is to appreciate the fact that the role of the operating system as it relates to process management involves things like creation and termination of the process themselves, right? Scheduling, right? Which, process is going to run next. Resuming or suspending a process, okay? Providing mechanisms for process communication, so-called inter-process communication, because it turns out that once processes are running, they communicate with each other. Anyways, so we see here that without process management, which is facilitated by the operating system, a 40 program, for instance, could potentially run forever in a loop, is it? Resulting in the entire computer crashing or something, or freezing, if you will. Okay, so that's process management, and then we again started our discussion of so-called memory management, right? So this notion that the other finite resources, important finite resource that your process needs to have access to is memory, right? So all of these different processes, if you look at this column called PID, this is process ID, right? Each process that is spawned on a computer is assigned a unique number, unique value, each and every one of them actually. In fact, if you look at PS3 or something like that, you'll be able to notice that I think I can kind of ensure that you begin to notice that each and every one of these different processes spawned, right? The very first one is system D here, process ID 1. Each one has a unique ID, right? So all processes associated with programs will have a unique ID. I have a program called Olama that has spawned all of these different processes, each with a unique ID. Each with a unique ID. What else? Is there Chrome somewhere at the bottom here? I like using Chrome as an example because I know most of you can easily relate to Chrome, right? So a whole range of processes, right? Each Chrome here, Chrome process with a unique ID. Okay, so it turns out that it seems we need resources ideally. So in terms of memory management, we did mention the fact that our interest, our discussion is centered around main memory. Okay, and main memory was defined, or primary memory was defined as a linear array of bytes, right? Each with a unique address. This is why they told us in 2101, or is it 111, that memory is byte addressable, is it? But also more important in our case, RAM is volatile. It is a constant supply of power. The moment you run out of power, everything that is in RAM is essentially going to go away. It will vanish like that. What else? This resource we are calling RAM here is scarce. It's finite, right? It's finite. It has got to be shared amongst all running programs, right? In my case, I have a series of programs that are currently running. All of those programs are typically, all of those programs need to have access to RAM. Now, if RAM is scarce, it's like how exactly, because all of current running programs cannot all fit into RAM, right? Remember that when this operating system, when I switch on my computer, what typically happens is the very first program, one of the very first programs that is loaded into RAM is operating system, right? For it to function, it needs to be in RAM as well. Okay, so now if all of these things that are running need to have access to RAM, begin to notice that it is not possible, right, for all of them to find themselves in RAM at any given point in time. Okay, so the operating system is there to manage the allocation of memory, for instance, right? True to that, actually, if I go back to this, you notice that for each particular program, and in terms of program here, forget about process itself. Look at the command at the end here, the column called command, right? Because it's the one that shows you the type of program or programs that are running. Each of these different programs, if you notice, are associated with memory, right? They have access to memory. It is the role of the operating system to track the usage of this memory, for instance. to allocate memory and to deallocate memory, because there are instances when, if you're like me, for instance, we'll start with use commodity machines here, like or phones. If you're like me, you begin to notice that, well, wait a minute. When was the last time I switched off my computer, right? Don't know. It's been a while, I think, probably more than a week or something. If I check uptime, right? So my computer has been running for 7 straight days without going off, right? Now in these 7 days, and the same applies to your phones, by the way, you rarely switch off your phone, right? Some of you probably have had your phones on for probably months, 2 months, 3 months or something without it going off. In all of that time, right, you notice that you have applications open in Chrome, in Android on my phone. Typically, there's a way in which I can kind of view all the applications that I have opened in the last couple of days or something. They'll be open quite right, but it turns out that not all of them will need access to resources, right? Because they're dormant. So it's the role of the operating system to deallocate memory for those sort of dormant applications, for instance. Allocate or reallocate memory to active applications, right? Amongst all the active applications, it is the role of the operating system to ensure that memory is being equitably shared amongst these different applications. It is finite, quite all right. So how do we ensure that each of these different running programs have access to memory? Well, you schedule, right, allocation of memory. But also the operating system is there to make available what we are calling quote unquote virtual memory, right? Also manage swapping. The key here to appreciate is that without the operating system, right, without memory management, without operating system managing this memory, programs would potentially override each other's data, again, causing your computer to potentially crash, ideally. Okay. So there's that. And then the other, function of your operating system is quote unquote device management, right? Now, if you remember your discussion of I/O devices or quote unquote input output devices, I think you probably had a discussion of you had a discussion of different types of I/O devices, right? You were told that your so-called I/O devices can either be input devices or output devices. The classic ones are input devices, output devices, storage devices, right? Some of them are hybrid devices anyway, right? But there are 3 main categories, right? So there are things like keyboards that act as input devices. You use them to provide input to your computer, so input data to your computer. So is the mouse, right? Whereas some I/O devices are actually output devices, right? Like your display devices, your monitor, is it? Your printer, right? When you're printing something, it acts as an output device. Your storage devices will include things like disks, external thumb drives, right? USB sticks, ideally. I don't know if you guys still use these things here, but there's USB drives, ideally, or your external CD drive, right? Or your internal CD/DVD drive if you're using an archaic machine, because your modern day computer doesn't it doesn't have your modern day computer system typically is not designed to have an internal CD/DVD drive, right? Those things they are old technologies. Okay, things have changed. But anyways, it turns out that because you have a whole range of these different devices, like currently, right? In my case, I currently have. I'm trying to see if I can check the type of devices that I have. I have my mouse, you know, some of these are integrated, right? I have my mouse, obviously. You can't see my mouse here, but I'm moving my mouse. So I have my mouse, right? Mouse. I have my keyboard, right? I'm providing input. What else do I have, right? Well, I want to plug in my I have a whole range of thumb drives here. It's old things I bought years ago. They're still alive here. But I have a thumb drive, is it right? It's mounted automatically. It's is it mounted automatically? I can't really see it. I need to I need to activate it for me to be able to mount it. I need to probably mount it. You'll probably be able to see it from here. I guess it's this one here, right? Which has a capacity of about 7.5 gigabytes. I can mount it right now, right? Just has some really odd things here, odd content, but that's neither here nor there. So I have my storage device there, right? In other words, what I'm saying is that at any given point in time, I've mounted it now. At any given point in time, right? Your computer will actually be associated with a series of input-output devices. These are hardware devices, if you remember, right? Things that you can see and touch, right? Hardware components. And really in Ubuntu, there's a range of ways in which you can check for hardware devices. I think there should be an ls hardware. ls hardware. Do a man on it, right? So I can list hardware using ls hardware. ls hardware. I probably wouldn't be able to so much verbose output, so but what I may want to do is just do that or something. So I can list different hardware devices associated with my computer, quite a number of them, right? You know, my graphics cards, you know, there's a motherboard and all those things, right? Memory itself is a hardware device, ideally. But also we can I guess kind of list input-output devices, is it? If we wanted to explicitly list input-output devices, there we go, right? Maybe we can use the input-output devices. That would be better. I can do a man here so that you can look up. So utility to configure and test X input devices, right? So we can list these things here, right? Is it? Anyways, so the long and short of it here is we're saying that your computer will have associated with it a series of input-output devices, okay? And it turns out that each of these different input or output devices is typically designed in such a way that they can handle one request at any given point in time, okay? What that entails is that your operating system is there or needs to be there to provide this uniform interface, which is going to make it possible for the hardware to interact with the CPU, for instance, right? So it doesn't matter whether you are using your mouse or your keyboard, the operating system provides this consistent or uniform interface, okay? What else? Well, the operating system is also designed in such a way that it will handle effectively interrupts, right? Because when you're using hardware devices, typically there's an interrupt signal that has got to be sent to the CPU to signal to say there's input that is coming from this particular device. Okay. Now, because at any given point in time, you can have you know, a user using a mouse and a keyboard, like I'm using a mouse and a keyboard at the same time here. Only one request can be handled by the CPU, ideally, at any given point in time, right? So it's the role of the operating system to schedule these requests, right, and figure out exactly how best to handle them. More importantly, the role of the operating system is to hide or to abstract the hardware details. And how does it do this? It does this through the use of what was introduced to us as device drivers, ideally. Okay, so quite a number of interesting things here as it relates to I/O devices, and we see here that without the role of the operating system acting as an I/O manager, without input-output management, you as a programmer would have to write your own low-level code, right? Associated with these different devices. And because you typically have a whole range of devices, it would be difficult for you to do this, right? Not impossible, but difficult. I don't know about impossibility. It would be difficult. I have to change this to difficult, right? What makes it even more difficult, by the way, is the fact that people are coming up with all sorts of wild ideas every day, is it? Even you yourselves, right? You discovered in 21, is it 01 or 2111 that you can come up with your own input-output device, right? And the only thing you'd have to do is come up with corresponding device drivers such that when you plug in that device into a computer, your computer will be able to recognize what it is and figure out exactly how to interpret signals coming in or signals going to the device itself, right? I don't know, this is how people have come up with weird things like, I don't know if you remember, I don't know if you had a discussion with about brain interfaces or something, right? It's becoming common here. I forget the example I normally give when I'm teaching someone. It's called Neuralink, right? So if you look at, if you study, let's say, if you study, if you look at this particular, if you look at this, if you've used this as a case study in 21, is it 01 or 2111, if you had a discussion of computer brain interfaces, you notice that these are nothing more than input-output devices. So there are smart people that came up with this input-output device which can be interfaced with the brain, but it turns out that the signals are actually sent to and from the computer, right? So all you do is you just figure out, what sort of signal is going to be used as input, and when it comes out as input, how should it be interpreted ideally? If this is making sense, right? I don't know if you guys had a discussion about those kind of interesting things that are currently coming up here, emerging technologies, if you will. Okay. So anyway, so that's that, and then there's also quote unquote file management, right? By the way, out of interest here, in which course did you discuss? You just type in the chat here. Which course did you discuss input-output devices? Is it 2101, computer systems or computer architecture or something? Or people have forgotten? You're just memorizing things, is it? People have forgotten where these things were being discussed here. I don't know where this thing is coming from here. See, people are talking about I'm talking about Olama here. We're not discussing Olama, but I mean, you can run Olama. 16 GB is more than enough, right? You can run Olama on the machine with 16 gigabytes. I mean, the only thing is you would need to restrict yourself to quantized models, right? So models that are much smaller, okay, which tend to be not as effective as the larger models or something. Okay, maybe it's just conversation taking place amongst yourselves here. That's fine. So it's 2101. That's good. That's good. Yeah, I don't think you can run a model with 8 billion parameters on such a machine. I don't know, maybe you can. Okay. So next up is, remember we said there are 4 main functions of the operating system, right? So we've had we spoke about process management, memory management, input-output device management, and then next up is file management, right? Now you had a discussion about files here in 2101. I believe you were told that a file is a named collection of data, is it, on persistent storage, apparently, right? So on disk or something. But there's something interesting here, especially as it relates to one of the case study operating systems we're going to be using, right, which is Ubuntu. The fact that this collection of data can actually manifest itself into what's called a directory, right? So on Ubuntu or on a Unix-like operating system, it turns out that, in fact, everything is a file, right? But for the purposes of what we're looking at here, a file is not only classified as an encapsulation of data, really, but it can also be a container structure. And what I mean by that is, if we go to our folder here, right, and I do a list here. In fact, maybe I go into slide or something, and I do a list, right? It turns out that on Unix, in fact, even on Windows, really, all of these are files, right? So this is a file, this is a file, this is a file. The only distinction is that this PDF document here is what's called a regular file, is it? Maybe if I use my file manager, it's going to be a lot kind of easier to explain some of these things here. Just go into this directory here. So what we were told was that this is a file. This is a file, but it's a special type of file. Why? It's called a directory because it's a container structure, is it? It can actually encapsulate or provide you with this illusion, right, that there are files that are associated with it. In fact, if you look at it at a very low level of abstraction, you just have pointers, right? It's not really like this folder here actually has these things inside it. This is done, right, for us to be able to understand or to interact with the computer effectively. This doesn't exist actually, right? It's an illusion, right? If that makes sense. So a file, in essence, is a named collection of data. And some other things that you discussed is, I believe, hopefully it was in 2101, you had a discussion of, the broad spectrum of file types that you have, right? How data is encoded, is it? There's certain files that are designed in such a way that they can hold what we call images, right? Some files hold plain text data, right? Some files, are designed to hold video data ideally, is it? Maybe something else that you may have been told is, I don't know if you discussed this, was the fact that not always the case that the extension type, although it's a good indicator, a signal of what sort of data you find in there, it's not always the case that when you just change the extension type, then the encoding of the data changes, right? No, right? So if I change this and I look at the properties of the file, if I change the extension to txt here, it will still have PDF contents, is it? And in fact, if I open it with Oculus, it will still be a PDF document, right? But the operating system, because of the way I've kind of like configured it, I've configured it to say, if you see a file with an extension of txt, it's likely it's a text file, and use this program, right, or associate this program to open that file. It's like a default program, is it? So that when I double click, it knows it. I've told the operating system to say, if I double click this file, use this application to open the file, something like that. The same applies to like image files, right? If I have a JPEG file and I want to, I double click it, the default application should be Gwenview or something like that, is it? If that makes sense. So a file is a named collection of data on persistent storage. A couple of interesting things here, right? The fact that this file sits on persistent storage, right? On secondary storage. So it can sit on internal drive, right? In this case, I can put it on my 800 and my 900 and almost 1 terabyte sized internal drive. I can also dump it on an external storage device, right? In this particular case, I have a thumb drive, which has 7.5 GB of data. Okay, and true to that, if I go into my if I go into my, I don't know why I can't get here. If I go into my, the share, I guess, the shorter. If I go into my external storage device here, 7.5 GB storage device, I have a whole slew of files, MP3 files here, ideally, okay? And some JPEG files here, is it, right? MP3 files and image files, ideally, audio and image files. Okay, so in terms of the resource, that we're most interested in insofar as file management is concerned, or more aptly put, in terms of the resource that the operating system is mostly concerned with insofar as resources are concerned, you're looking at disk space, right? Again, disk space is finite, okay? You only have so much. At some point, you will run out of disk space, at which point you have to delete other files, okay, or extend the disk space somehow. Typically, deleting is the way to go. Like in my case, I currently have like 1 terabyte of data of internal storage, right? It's 938 GB. Out of these, 94% of it has been used, is it? So I've used 837 GB. I only have 54 gigabytes remaining. Very, very soon, I would have to figure out a way of making sure that I have more space, right? Because I'll run out. Every day, I occupy more and more space. Why? Because there are certain activities on my computer that result in the creation of additional files. And because each file occupies space, more and more space is going to be used. Right now, as we speak, I'm using an application called OBS to stream this class. But as I'm streaming this class, I'm also recording, right? If I go to the location of where this is happening, you notice here, I have this file, right? 114.5 GB. It's now 114.6. It's changing, it's occupying more and more space, right? Why? Because I'm creating data, right? I'm recording this screencast at any given point in time, every second. There are frames, right, that are being dumped on disk. The long and short of it here is that storage space is finite. It's a resource, one crucial resource that is associated with file management. And so it goes without saying here that the roles of the operating system as they relate to file management include things like creation, deletion, opening, closing, reading, and writing of files. So the operating system is there to facilitate the creation of new files. Now, this creation of new files is interesting, isn't it? Because it can be done in so many different ways. But primarily, these different ways are done using they're done using computer software. For instance, literally right now, like I said, when I started streaming, there's a new file that was created, this MP4 file. It's a video file. It was created because I'm streaming. It was created by this this computer software called OBS, this thing here I use for streaming. Okay, OBS Studio. What else? Well, if I wanted to, this file here called, it's Untitled 11 here. I've created this file, but I haven't saved it yet. If I save it, I would have created it using Kate. Okay, so the role of the operating system is to facilitate the creation of files. Not only that, the operating system will have functionalities to facilitate the deletion of files. Typically, you'd use, when you're deleting files here, you typically would delete files using a feature of, or a piece of software. I'll call this a feature of an operating system called a file manager. Use a file manager. Like my preferred file manager is called Dolphin. Okay, so what you're looking at here is Dolphin. I like the aesthetics of Dolphin, and also I have more control, right, over what is happening here. So if I go on help here and I go on about Dolphin here, the current version of Dolphin associated with my version of Ubuntu here is version 23.08.5. Okay, so it's a file manager. And there's a whole range of file managers. I don't know what sort of file manager is available on kind of like Windows these days, really. But I remember back then it was Windows Explorer. When I haven't used Windows in a long time. I don't know what has come of file managers now on Windows. Maybe there are more fancy file managers available there. Don't know, don't care really. But the key thing here is that the operating system will facilitate this through the use of file managers. Now, I don't know, I'm tempted to kind of demonstrate this on. Let me just yank this out. I hope this works. My cable, this one, is non-functional almost, right? So I'm going to plug in another device. This is interesting now, right? Because I've plugged in my phone, right? I've plugged it into my USB drive, but it's now considered an I/O device, is it? You know how when you plug in to your USB port, your phone, what happens is it will be treated as an I/O device, right? So my phone has become an I/O device. And the reason why the computer is able to identify it as an I/O device is because there's this uniform interface, if this is making sense. So what I'm going to do here is I'm going to demonstrate something quickly. I'm just going to, can I kindly ask, do you want to mute yourself, please, right? I don't know who you are here, if it's Liswanis or something like that, I don't want to have to reconfigure these things. I usually leave it open here because I would want you guys to, wouldn't want to waste time when it comes to doing some of these things. It's not that hard to mute, right? It's easy to mute your device. So let's see if I can connect this or something. There we go. That's my phone right there. So my preferred what do you call this? See, I'm logged on here as well, so I'm just going to close this here. One of the file managers, right? I've been using for a very long time. It's like a third-party file manager. It's called Astro. This thing here, right? And one of the things I like about Astro is I can actually link storage devices, but also actually when it comes to managing my file system on Android, it does a really decent job of this, right? So I can get a sense of where most of the space is coming from, right? It's classic file management here, so that I free up the space, right? So I can organize this based on things that are unused or something, or based on storage or something like that. But probably I can do something like going to documents or downloads, and then kind of sort these things by I guess by size or something like that, right? Descending or ascending or something, and be able to delete here. But the reason why I like this is I can actually link. If you look at storage locations here, right? Currently, I only have internal storage, right? It's like 256 gigabytes. But I can link my storage, my cloud storage ideally. I can link my Dropbox, my Google Drive, my OneDrive, so that I have access to all of these different storage locations. External storage, if you want to call it that, right? Anyways, it's neither here nor there. Just going to, maybe I'll leave it open so that I can demonstrate other issues to do with file management, ideally. Yeah, so you have your operating system fundamentally using what's called a file manager. In fact, I think on Android, they should be, I could be wrong here, but I think the native file manager is called Files, I think. Is it? Yes, it's called Files. I have it on both my work account and my personal account on Android, right? So if I go on Files here, so the interface you notice is kind of like I mean, use this in a long time. It's just going to update later. It's kind of similar to your typical file manager, right? Because the role of a file manager is essentially the same, right? It's managing your files, right? Management of a file system. And management entails things like deleting files, right? Rearranging or reorganizing files. So I'm going to create subdirectories and organize my files in a certain way. So I'm creating new files again. I don't know. I don't know what else I've never used this internal thing yet. I don't know. I prefer Astro myself. But it turns out that you can also link things like Drive using files, right? Anyways, so file management, right? A crucial part of operating system, and we see here that fundamentally your file manager is what the operating system kind of like uses as a way to help you manage your file system ideally. So the role of the operating system is to help with creation of files, deletion of files, which is pretty straightforward. So using your file manager, you can do a right click in here. I can right click and say, I want to delete this, so move this to trash or something. Okay, we'll delete it. Or I can use other utility I can use other utility tools, right? Like RM, right? I want to delete here, RM, remove, right? RM, right? Remove files or directories. Okay. If that is making sense. What else? The operating system facilitates opening of files. And again, this is kind of like it's provided typically through an interface, right, associated with your file manager. So in my case, my file manager called Dolphin allows me to right-click and open a file, or open with, or something like that. Okay. What else? My operating system has a feature in this particular case. The Ubuntu desktop environment allows me to use this application launcher to open whatever file I wish to, whatever file I want to interact with, right? But implicitly, I'm doing this using application software. Okay. Anyway, you can close the file as well. Again, implicitly, you'd be doing this using maybe application software or something. But in addition, what the operating system does is it allows you to read the contents of the file. Again, reading is not explicitly done by the operating system, but via some application software. For instance, when we were starting class here, what I did was I used Ocular to read the contents of a file on which is on disk here. There is this file. Where is it? I don't know. It's here. There's this file, right? This file here. The name of the file is notes-126-CSC 2202-lecture-02.pdf. So what did I do? I said right-click and I said open with Ocular. When I open it, what I'm doing is I am reading the contents of the file. Is it? I'm reading the contents of the file. And there's something interesting about reading the contents of the file, is that not every piece of software can be used to read the contents of any type of file, right? So it has to be specific or appropriate for the data encoded in the file. For instance, I cannot say, well, I can open, quite all right. I can open, updating the website here for research students I'm working with here. I can, the text editor called Kate here. I can quite all right open I can open a JPEG file, but because of how data is encoded, this file here is not designed to be opened using a text editor. So what I'll do, what will happen is I'll see gibberish, right? Is it? I mean, there's some text here that perhaps is going to be kind of like legible to a certain extent, if you will. But for the most part, this will be stuff that I can't even understand, right? Why? Because reading of the contents here is best done using an image viewer like WinView, right? So I'll open this using WinView, and I'll be able to see an image or something. Or I can open this using GIMP or Photoshop or something like that. Okay. Anyways, so that's file management, right? You can also write to a file. Now, typically, again, writing to a file is not done directly. So if you're an end user like me, the operating system doesn't directly write to a file, but what happens is end users make use of application software. Okay, so in my case, I will use application software like Kate, right? Kate to write to a file like this, edit it, right? Write to a file so that I add new data. Okay, and then implicitly behind the scenes, when I write to a file, I can use this as an example actually. What file is this? It's a transcript for one of the courses, I guess. I don't know why. I just trying to use this as an example. A file, this file is using, yeah, it's using, I'm just going to do this in bytes, is it? It's occupying space on disk. How many bytes? Right now, this file is occupying 93,545 bytes, right? This makes sense. 3 bytes, right? Now, if I write new content to this file, this is new content that must be deleted later or something. If I check this, right, I have not written this data to the file because the changes I'm making are in RAM, isn't it? For this to persist, I'll use this application software to save. When I save, the resource being occupied by this file is going to be significantly more, right? So if I check now, this has increased from 93,545 to 93,594, is it? Surprise, surprise. It's almost like, I don't know if you remember this here, but guys, this minus this, minus this, 49 bytes, right? 49 bytes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I'm just going to count this. How many characters are these? This is 40. If you look here at the bottom, I don't know if you can see at the bottom here, 47 characters, right here. 47 characters. What did I tell you about ASCII, right? I don't know if you remember this about ASCII, about how these files are kind of like created, right? I don't know how much of this you remember here, but you have your ASCII table, is it? And your ASCII table, each character can be represented using a series of bytes, right? I don't know if you remember this from, is it computer? I think it's computer systems. It's computer systems. I don't know. Let's see here. You have, just remind you guys, in case you've forgotten, right? They told you about the, I don't have the ASCII table, but you can find this let's see if we can find this. I think it should be there on Wikipedia or something. Goodness. I don't know if you guys remember this, right? This is where you, I'm not assume, I'm assuming here, by the way, literally, I'm assuming that these were done to us. We're going to revisit some of these things here. You remember this? Where they said, that you can literally represent this. You can represent each character here into its equivalent size, right? You remember this? I mean, you have a hexadecimal kind of like representation and stuff. So if we were to assume here, right? If we're just to assume that each character is 8 bits, in other words, I'm going to copy this here. It needs to make sense here. I'm going to copy this and I'm going to dump it here. Come on. I'm going to copy this here. I'm going to dump it here, like so. It's text, right? Now here's the thing here. Each one of this sentence here, yeah, a new data that I've written to a file, which has resulted into, I'm going to come back here so we don't lose track of why we're doing this, right? We added data to this file, right? We are writing to this file. We wrote data, new data to this file. It's like a sentence, this sentence. And we notice that the space occupied by this file suddenly increased. It increased by what order of magnitude? Just 49 bytes, right? Because this is in bytes here. It increased from 93545 to 93594, right? Difference is 49. Now, it's like, oh, if the difference is 49, then it has to be approximately equal to the size associated, because it's an ASCII encoded file. Just assume it's an ASCII encoded file. It has to be associated with each one of these things here. Now, it turns out that each character, for instance, the first character is, why now? The first character is, I hate some of these ASCII table. I hate this. This is not what I'm looking for here. But each character is 8 bits. And if you remember, they told you that 8 bits is equal to 1 byte. Right? So if 8 bits is equal to 1 byte, then each one of these, the T here, the H, the I, each one of these is occupying 1 byte. 1 byte, 1 byte, 1 byte. So if we just count the number of characters, we can just multiply by 1, right, to get the number of bytes. Why? Because we see that one character is equal to 1 byte. The number of characters we have here, I counted them last time here. It says 47 here. There are 47, right? 47 characters. Meaning that whatever it is we are writing here has got to be somewhere in the 47 bytes, somewhere there. You understand? And I hope these are really 47. I don't know if they are actually 47, but one. I don't know if this is actually 47 characters here. Maybe, maybe not. You know, the easiest way of figuring this out is doing this. Doing this, but there's a space afterwards here. There's a space afterwards here. Okay, I mean, I'm going off track here. We don't have to do this. We can, but you know, we can also do this using Dr. Nyirenda taught us. We can confirm how many characters do we actually have here. Dr. Nyirenda taught us this. I guess, I don't know, in Python, right? I don't know why we're doing that actually. So string here. Yeah, splitting again here is going to, well, you know, it seems like in here. This is becoming insane. But we're doing revision here, is it? We're doing revision again, so which is going to be good here. And same thing as say count is equal to 0. Let's do revision, is it? Count. There we go, and then I'm going to print that out. Okay, so it's still 47. It's still 47. But the thing here is that if you look at this, there's probably a new line here. Here, right here, there's a new line here. If you notice here, and this is how Kate works actually. But maybe one of the things we can do is I can open this file and not use Kate, but try and force this. Right, I'll go at the bottom here. There's usually a new line character that is created by Kate, right? So, but in other words, what I'm saying here is that when you're writing to a file, like in this particular case, plain text file, the encoding that is being used here is kind of you can figure out exactly how much new data you're going to write to a file. It has got to correspond to the size. The new size is going to occupy on disk, ideally, right? This against this. Anyways. So there's that, right? Writing, you can write data to a file, but writing data to a file requires the use of application software. What else? Well, we see here that the operating system plays a role of organizing your files, right, into directories. Not only that, but the organization is also tied to naming conventions, right? So it allows you to organize them properly by providing appropriate names, and also, nesting files into directories and subdirectories. And the classic example I have here is how I normally would organize my data in my case, right? So I organize my data in a certain type of way, right? I have my home directory here, and then for work-related things like teaching, I will have subdirectories corresponding to this, right? So for work, I'll have a year, so that I've cleaned up my computer, but I typically have different years here, right? 2025, 2024, and stuff like that. If I go in a particular year, I will have directories or subdirectories associated with the different courses that I teach in that particular year, right? So in this particular case, if I go to 2022 to 2202, I will then again have subdirectories corresponding to different activities or things we're doing in 2022. Right, I have one of the things as being slides directory where I put lecture slides, and each lecture slide is associated with a subdirectory. And the reason I do this obviously is because as I am creating slide decks, there are visualizations that I generate, right, that I use to actually construct the slide decks, the slides themselves, the notes. Okay, so the operating system is the one that is providing us with a very user-friendly way of organizing these files on the file system. And typically, typically this is done by your file manager. Of course, there are certain applications that you can use, right? The file manager in this particular case called Dolphin is showing me a visual representation of how my files are organized. There are other nifty features I can use, like right within the current directory, I can just expand this and see, right? So I have this kind of tree-like structure, nice structure that allows me to locate which particular file I'm interested in my tree, for instance. Of course, there are other kind of applications that come bundled with operating system by default. And I think there's 3 or something. See. Okay, I need to install this. Wow, I didn't know this. The other utility software tools that you can install, right? So in this particular case, I can just install 3. 3 has always been my personal favorite when I'm using, the terminal, ideally. So what it does is provides you with a visual representation of your directories, right? Of your file system, ideally. So given input of a directory on a Linux-like operating system, in this case Ubuntu, it will show you a tree-like structure, okay? tree-like structure, a nice visual, a visualization of how your files are organized. I haven't used this in a long time, but there we go, right? A nice visual structure, which is usually quite useful, I guess. And I guess you can feed it with more, it's even color coding, right? You can feed it with more information. If I go into 2202 here, from the run tree, from right within here, right? I have a nice tree-like structure on the terminal, right? So I see here the directories in this folder: administration, assessments, code, playground, and stuff like that. But anyway, so the thing here we're trying to appreciate is that one of the crucial aspects associated with file management as it relates to operating system is it organizes your files into directories. What else? Well, it provides protection, and this dedicated kind of function here we're calling protection, right, and security here. But as it relates to files here, it provides protection, right, permissions ideally. Now you remember from 2101 that permissions in Linux are quite interesting, is it? Permissions in Linux are done in such a way that, I'm going to go into slides here. They're done in such a way that they're associated to the individual, to the group, and to everyone else, right? Individual, group, and everyone else, is it? Individual, group, everyone else, right? So you have these three characters here. I don't know if you remember this, right? Read, write, execute, right? So each file on the Linux-like operating system is supposed to state whether the owner of that file has read access, write access, or execute access. In fact, this is the reason why this is the reason why you are told that given a file here, can I given a file, right? Like in this particular case, this file, this text file is a PDF file, really. You can use this command here to just rename it, I guess, what it was PDF. But given this file, right? Given this file here, you notice that it's associated with permissions, specific permissions, right? I'm going to copy this here to remind you of what happened in 2021 or something. Delete this, delete it right now. But you were taught something interesting, right? That on a Unix-like operating system, right? Owner, right? This is a group associated with the file itself. The size on disk, right? In bytes for now, right? In bytes. How do we know it is in bytes? Well, we can derive this. This is in bytes, right? We can convert this to kilobytes, right? We can also convert this to megabytes, right? 1024, right? So it's like the size of this file should be somewhere around 13.6 megabytes, somewhere there, right? If bytes is confusing for something like this. So if I do this in terms of human readable form here, you notice it's close to 14, right? So it's because it's like 13.6. If you round it off, it's 14 megabytes or something, right? So it's the size, the date when I believe it was created, right? And stuff like that. And I think the time when it was created, and then the file name, ideally. But in terms of the permissions, right? Observe what they told you was that this first marker here at the very beginning here tells you what? Type of file. Type of file. There are two types of file in the Unix-like operating system. Regular file, right? Regular file is equal to this. Directory is equal to D. There's a reason why. If I come here, right, directory, the thing that is in blue, D. Directory, D. Regular file. It's not a container structure. Minus, hyphen. What else? It told you that these groups of 3 characters, right, will represent the permission for the owner or something. I don't know why we're wasting time. It's owner. That's in things that were discussed already here, right? And they told you that R is equal to read, W is equal to write, X is equal to execute, minus is equal to nothing, right? Negative or something. So there's an owner, there's a group, and then there's everybody else. Everyone. And so the idea here is that whenever you're working, playing around with permissions, right? When you're playing around with permissions, it turns out that you are specifying to what sort of permissions you are giving to the owner of the file. I know it sounds a bit strange here. It's like if a person owns that file, right? Why would you have to specify a permission? Well, it turns out some files don't necessarily have to be executable, for instance, right? In some instances, it could be a sensitive file and you don't want the owner to even be able to write to the file and stuff. And this really is exemplified even more if you start looking at the root structure of the directory in Linux, right? So if I come here and I say, I'm going to context switch, we're doing a lot of things. I'm going to context switch and go to the root, right? If I go to the root here, where am I going to find something interesting here? Swap file, right? The swap file, right? Who is the owner and stuff like that? I'm going to do this. Look at, surprise, surprise, right? The owner is root. And the reason why I can see this here, I have sudo access. Owner is root, group is root. Set groups. Groups. So these are the groups I'm associated with here. I'm part of sudo, right? So I can probably, you see this? I'm part of sudo, a user, sudo. Forget about this. Look at this when you look at permissions in detail here. This is what we're doing in this course. But look at this, right? It's like the swap file, the owner has read and write access. So the user root can read this file. Surprise, surprise. The user can also write to this file, right? Who is root. If I attempt to open this file using VI, I know swap file here is like, what sort of file is this? I don't even have access to read this, right? No permission. You see this? It's a regular file, quite right, but I don't have read permission. Why? Because I'm not root right now. I'm not done as Lighton Phiri or something. What I can do here is, I guess I can switch to root or something. I can log in as root. Hopefully I've got to log in here. Root. There's a thing here. I don't know if I have come on really. Okay, that's fine. I'll do this su then. Fair enough. I'll log in as root, right? So if I check, I'm root right now, right? And if I do a list on swap, I can see details, right? Previous I was unable to because it was telling me, listen, you don't have access to this file, so you cannot read the file. If this is making sense. So anyway, what I'm trying to remind us is that we discussed this in 2101 here, is a case study for Unix, right? But what I'm trying to remind you is that the operating system is there to provide this fine-grained, or to provide fine-grained permissions as it relates to files on your file system, right? Protection. You understand this? What else does it do? Well, it helps you manage free space on disk. How does it help you manage free space on disk? It comes bundled with, I'm going to exit here. It comes bundled with, utility tools, right? This comes bundled with operating system like DF, right? I can manage space by analyzing the space, right? How much space do I have? Okay, I have 94% remain. Sorry, I have 6% remaining because I've used 94% of my disk space, my internal storage. Okay, so what can I do here? Well, I want to figure out exactly where I should delete this space. Fine, I'll use another utility software tool that comes bundled with operating system called DU, right? So I want to estimate file usage for the main directories, right? Level 1 directories first, so that I have a sense. And it starts telling me, right? You have a folder called right in your base, because I'm here right now, observe. Oh, I'm in root. I'm going to delete here and go to my home directory. In my home directory, right, I want to figure out, right, the amount of space occupied by the different level 1 directories here. And I can already see here, oh, there's a folder called VirtualBox virtual machines, right, which is occupying quite a bit of space. And I'm focusing on the G's, right, the GB. I'm going to ignore megabytes, and this is not really important, and stuff like that, right? So I'm using operating system software to analyze. I say, oh, downloads as 18 GB. That's insane, right? Because I know that typically in my downloads folder, I'll have temporal files. And because I have temporal files in my downloads folder, what I can do as well is I can use operating system level utility software tools like LS to list these files, right, in a certain order. So I'm going to list them in reverse order of size, right? And I'm going to make sure that this is in gigabytes here. So I'm reversing the order so that I see the largest ones at the end. And I see, oh, I have files like these lecture recordings, right? And probably I've already processed them and I've already dumped them on YouTube. So what I can do is to reclaim this space. To reclaim space, because I only have 54 GB available and counting, what I can do is I can delete this file for CS 2202 here. Why? Well, I know I already processed this. I'll delete this so that I have slightly more. I have now available is 54. If I delete this, remove, right, RM, I will have 56, right? What the operating system is doing is it's helping me manage this free space on disk. Now, what I wanted to showcase here is that there's a lot that is involved in terms of managing free space, right? You manage free space first by analyzing, okay? You use utility software tools, which are system software, to analyze space usage. And then you use utility software tools that are going to help you delete or backup files. So you move them. What I could have done here is I could have said as an option, I am going to, instead of deleting, because I haven't backed up the file, what I'm going to do is I am going to move the file, this file here. As a way of managing, I'm going to move, I can use tools like rsync, right? But in this particular case, I will move this file. Where am I moving this file? Well, I'm going to move it to my external storage, right? This. If I move it, I will have slightly more. Instead of available space being 56 GB, when I move this thing, the amount of space is going to be obviously significantly more, right? Maybe 57 or 58, somewhere there. Because this is 1.4 GB or something. And obviously it's going to take a while here because I'm moving it to, you know how moving to an external IO device is usually slower, right? So it takes a while before this process kind of completes here. Now, the key thing here is that, and it's my thinking here, is that implicitly under the hood, it is the operating system that is helping you do this, right? But you have these interfaces in the form of utility software tools that are helping facilitate the management of free space. I think part of the reason why this is slowing down is because it's a bit slow here. The file is large, obviously. And typically, right, what would be faster would be, I don't know if you remember this, the way we manage space by way of deleting is, we have two options, right? We move this file from external storage, from internal storage to external storage using the mv command, move, right? Or what we would have done is we could have said, we are going to copy the file to external storage. Dude, why is this thing taking long? We're going to copy the file to external storage, and we can check, by the way, whether this is working, right? I'm going to come back here. We're doing a lot of things here. I'm going to come back here, and I'm going to change directory into this podcast. It's this file here. It's done now, though. I don't know why it's done. It's complete. I don't know why this is still running. This is insane. This is still running. I don't know. I'm not doing this here. It's 77 at the end. It's done. I don't know why it's still running. It's done though. I don't know why this is still running. But one of the other options we could have done is, and it's even misbehaving, I'm going to do this. It's this thing here. Done. Why is it still failing? It should be. I don't know why it's done already, but I don't know why it's not there. One of the other options why it's failing. One of the other options we would have had is we move. I'm genuinely concerned here that this thing is not. I know it's in downloads. I'll go back to downloads anyway. And see if it's still there. It's still there though. One of the other things we could have done is, or maybe this is a different one because this is 19. This is it's still the same one. I don't know. I would have to. I'm sure I'll find it and I'll kill it down. One of the other things we could have done though is, because when you're reclaiming space, right? There's two things you can do. There's a couple of things you can do, but this particular case, two things you can do. Option one is you move from internal to external. Option two is copy and then delete, is what I would normally do. So I would first of all copy the file, right? Copy from internal to external, and then delete from internal. It's one and the same thing, right? It's exactly the same thing. By the way, we see here that the operating system actually does management of the file system or something. Do you mind, right? I don't know who that is here. The baby is crying in the background. I don't know if that's your brother or your sister or something like that, or your cousin, your child. Please mute your microphone wherever you are. Right, so file management, right? But there's quite a lot that is involved in terms of file management, right? Because what you notice is that in an operating system, right, file system, we were told that these file systems, right, we're going to visit some of these things in great detail, really, but typically your file system is associated with a type. Okay, and what I'm going to do for this to make sense is I'm going to use KD partition manager. Okay, When I was a student myself, we used to use a lot of, back then, right? There's a tool called Petition Magic or something. I don't know if it's still there in Windows. We were so obsessed with that piece of software. Well, there were very few kind of like tools you could use for that, right? It looks like it's still around here. It was quite nice here. But um, typically uh, each disk, right? Because file management is associated with what? With disk, right? If you remember this, I don't know how much of your computer systems you still remember here. So this notion that we are mostly talking about the thing that is used to store data. Now, when you're storing data, they told you that there's a difference between a storage device and a storage medium. Okay? The device is the thing that facilitates access to the data. The medium is where the data is written to. And to that, this is the reason why you have things like DVD drive, or maybe not DVD is. I want to use a classic example here would be. Okay, it's a DVD drive, and then there's the DVD itself. The DVD is that optical. The DVD is that optical thing, right? That you purchase. You go to some store or something, or you want to write data to your disk operating system. You go to your friend. Can you burn this on my behalf? If you still do that, the drive is the thing that you use to either burn, right, or write data, or to read information from there. Now, this is like a bit confusing here because sometimes these things are encapsulated into one, right? Like your external disk, this thing here. Where is that? This, the one I've mounted on SDA1 here. You know, it's a SanDisk, right? It's a very small. Let's see if I can find it here, so that we don't want to be abstract about these things here. I'll just say SanDisk 7.5 flash drive or something. It turns out that these things are designed. Literally, the one I have is I have a whole bunch of them actually. Literally, the one I have, like, I guess it looks like it's this exactly the way it looks like. It could be different or something. Because I bought these things a long time ago. Literally, I bought them, a whole bunch of them, because I was conducting experiments for my doctoral studies. So I bought them back in 2000 and that must have been 2017 or 16 when I was doing that experiment. It's been like 10 years and it's still there. And I remember, I think you were taught about lifespans of how you evaluate these storage mediums, right? So the thing about this thing here is that the thing about this is that you see this, it has both the drive and the medium in one, right? So usually some people kind of misrepresent or they use these words interchangeably. But I'm saying all of this because when it comes to file management, the management is not on the I/O device, but where data is being written to, which is the medium. Do you understand this? The medium, right? Because we are writing data to the storage medium, we are reading data from the storage medium. But for us to read data, we use an I/O device called storage device, if that is making sense. But anyway, so we realize that these things are actually associated with different file systems, right? Is it? Like in this particular case, the file system associated with my disk here is FAT32, right? A number of them, right? Some of them are specific to different types of operating systems, okay? Some of them are like ext4, for instance. This is like specific to Ubuntu, right? And stuff like that. And you discuss this, right? You know, I know this because I want to unmount this, I guess. I'm going to unmount this first, and then I'm going to see if I can but I wouldn't want to delete this here. Maybe if I plug in something else that has, I should have something else that has, I want to plug in something else, which I have right now. This is Ubuntu, okay, and this is an older version of Ubuntu. So I'm gonna refresh so that I see the one that has Ubuntu, and I believe it's this one, right? It has an ISO image here, because I mean, 17 is, it's just old, it's a cake here. So the thing here is that what I can do is I can say I want to manage this, right? And the way I would manage this is I would say, I don't know if this is already mounted here. I'll have to unmount it, I guess, first for me to, yeah, this was back in 2017, actually. 2017 when I was burning this thing here. So I'm going to unmount this. I want to unmount this. Safely remove. I'm trying to see if I can. This is unmounted. I'm going to refresh the devices here. I wanted to demonstrate something interesting, but it looks like this thing is not working. I'm just going to remove this and then plug it back in so that you can see. I really wanted to demonstrate this. It's back on. Connected it or something. So this is it. I can delete these things, I guess. I'll delete these things here. Okay, so now that I've deleted these things, what I can do is I can create a new, like if I want to create a kind of like a new petition on the storage device, one of the things that you do, right? And again, this is utility software too, but under the hood, this is an OS function, right? You have got to prepare the storage medium. And part of preparing the storage medium entails you specifying the file system type. And there's a whole bunch of them, right? NTFS is quite common for Windows, FAT32, FAT16, ext4, ext3, ext2, these are Unix-centric file system types. Now, there's something interesting that you were told, right? The fact that when you're creating a file system type, there's so many different things that you've got to take into account, right? Because the behavior of the operating system, insofar as file management is concerned, is dependent on the type of file system. Like, for instance, right, the maximum, things like maximum file size you can create, right? So certain types of file systems have a limit. So you cannot create a file that is more than, let's say, 10 megabytes, 10 GB, for instance, or 2 GB. Or file name limit, character limit. Right? So for instance, if you wanted to create a file name, this is a long file, .txt. Right? This is a long file, this is a long file. The file name, as in how long can this name be? It turns out that this is also dictated by the type of file system. And true to that, really, I guess, I don't know if there's file system types, a comparison or something. I think you should have like a Wikipedia curated page for this, right? That kind of showcases the things I'm talking about here. But this was discussed, I think, in 2021-01. We are going to revisit these things in great detail so that we have an appreciation when we get to our discussion of file management or something. Creation timestamp, access, not necessarily what I'm looking for. Capabilities, symbolic links, metadata journaling. So these are different sort of things that you look for, right? When you're preparing the file system. And here's the thing, right? It turns out that file name, file size. I want to look at file size. Maximum file size. I don't know if you've come across this. You have like an external USB drive and you have space, right? But you're trying to copy a file from your internal storage to that external device, and then you run into this error. It's like, why can't I copy this file? maybe it's a high resolution like file or something. I'll look at FAT32, like FAT32. It's a movie that is maybe 8 GB, right? Or 8 GB, and you have this storage device, right? SanDisk. But the storage device itself is created using FAT32. The problem with FAT32 would be that the maximum size is 4.29 GB. But if that file is large, you will fail to copy it there and scratch that, right? Forget about the video file or something. But let's say in CSC 2202, Lighton tells you to say, I have made available an ISO, right? That will allow you to create to allow you to install the operating system. I've made available the Ubuntu operating system and also the Windows Server operating system, the ISOs. You download it, or you're trying to copy it to your internal storage, and then it fails, right? But you have space, and you'll be scratching your head sometimes. You even, I'm sure at some point you've even thought maybe there's something wrong with my flash, right? But it turns out that it's tied to the file system, right? So this file, for instance, even if I was to purge, I don't know if I can do a test here. I'm going to do a test for you, right? In here, this it's a 7.45 GB. I'm going to change this into FAT32, and then I'm going to call this CSC 2202 experiments XP as a label, right? I'm going to apply this. Yes, I'm going to apply. I don't care. I'm going to apply this, right? So again, this is operating system. It's allowing me to kind of like I've deleted the existing file system, and then and it's done now. I've created something that is completely new. Right? I think it's mounted. I don't know if it's mounted. I'm going to come here and try and see. It's not yet mounted. I'll come here and I'll mount it. Right, the one that's experiments. This one. I'm going to mount it. I've prepared it. I've mounted it. Right. It's now appears as my external drive. I can mount even the other one which has podcasts if you wish. Mount it because I've unmounted it. And then I will do this, right? So I have these two things here, these two. So what I want to do here is, if you notice, I have enough space, 7.5 GB, okay? And what I want to do now is I want to move, unless the things a cake here. I'm going to move this file. Observe, it's file which is 6.1 GB. 6.1 is far less than than the capacity of my storage device, isn't this? Because the free space is 7.5 GB. So what I'm going to do here is I'm going to use Arson so that we do this, we simulate this, right? I'm going to move this Ubuntu file, ISO, to this file here. I guess maybe to work, maybe things have changed here. Maybe things have changed or something. I don't know. But the idea is this, you know, this would actually this would be the reason why you want to seriously think about the type of file system that you want to use. It's not just this, right? It's like there are some things that you probably would take for granted because you mostly have not worked with server computer systems. Right? So if you're working on a server, for instance, the type of file system would be an integral part of what you do as you are preparing that server for deployment or for use, if you will. Right? Anyways, I'm going to check this towards the end to see what will happen. It will take a while here because clearly it's not my computer, but it's a storage device. If you look at the speed, right, the throughput here is quite low, is it? It's fluctuating quite a lot, but it's quite low, right? It's not as fast. So it'll take a while before we can move the entire 6 GB here to the external storage. My external storage device is, like I said, it's like more than 10 years old. So the technology back then was much, much slower. It's so slow actually that if I was downloading this from using MTN or something, I'll probably download it much quicker than moving it to my external storage, which is quite strange, really. Not really strange, which is bizarre, I guess, but it's strange, I suppose. Shocking is a word for somebody like you, I guess, who has no experience with other technologies. Okay, so the long and short of it here is that without a file system, your programs would have to manage the raw disk sectors, right? Themselves, ideally. So you'd have to design these programs so that they're able to manage these raw disk sectors on their own, right? But the operating system provides us with this layer of abstraction. Okay, so instead of getting access to the storage medium itself, what we do is we go through it, or implicitly do this using files, right, in directories, ideally. What else? Well, the other feature is protection and security. Sorry, the other core function is protection and security, right? So our definition of protection here, I don't know if you've already done some computer security course here, is we are referring to the mechanism within the OS that allows it to control access to resources, right? There are resources that are extremely sensitive, right? They can potentially mess up your computer. So you control access to those resources. What resources are those? You say disk management. If you notice, if I try to open up this application, it's partition manager here, right? This is a very sensitive operation. Before I gain access to this feature, I have got to supply my credentials, right? So there's controlled access to this feature. And the only reason I have access to this is because I have sudo access, right? Like super user access, right? If this is making sense, right? So the operating system is controlling access to these things. What else? There are sensitive files on the file system. Like I showed you the swap file, right? If I do a file swap, ls swap file, I have no permission, right? There's controlled access here. How do we know there's controlled access? Well, we check the permissions, right? Only root, right? Or users that are part of root have read and write access. So sorry, only root has read and write access. Everybody else has no access. Remember this? The first one, the type of file, this is a regular file. If I check here, file swap. It's a regular file, right? In fact, if you want, you can play around with these things, by the way, right? You can do a cut. It won't really help that much. If you do a cut for swap file, you just see gibberish here, right? It's stuff that doesn't even make sense here. Why? Because it's like some binary file or something, right? Some binary file. But back to this thing here. So it's like only root has read and write access to this file because it's sensitive, right? There's controlled access. The group, even though Lighton Phiri is part of the root group, he will not have read access to this. Everybody else in the system will not have access to this. If you notice, where am I? I'm not logged on as Lighton here. I'm logged in as root, right? So if I exit here, I'll no longer have access. I'm still here. I can still see swap file here. If I say swap here, it's controlled access, not permission, no read permission. So you're controlling access, okay? And controlling access means, for instance, you perhaps would not be able to install applications. So if I say I wanted to install an application here, like update install, what do I want to install here? Okay, tree. I don't know if it's there. I can't, right? Permission denied. There's controlled access, right? This is operating system. I would have to do a sudo, right, to do the installation. Okay, so the thing here in terms of what the operating system protects here is it's the resources. And surprise, surprise, right? The resources that are being protected are actually tied to these 4 key things we've just discussed here, right? Processes, memory, and stuff. So you'll notice here that the resources that are being protected are files, memory, I/O devices, CPU time, and user data to a certain extent, right? Although user data here falls in the category of files, we need to be honest. But what we're trying to signal here is this notion that if you are working on a piece of software that allows multiple, all software tools allow you to create multiple accounts, right? You don't want a person who has access to the computer to be able to gain access to other user files, other user data, unless if they have super user access. So on those computers in the labs, right, at the department, you probably have accounts that you use to log in, right? But if you know the username for your colleague, you will not be able to gain access to their user data. It's protected like that. That is the OS at play. Now, the long and short of it here in terms of the responsibilities is, for instance, its role, that is the operating system, is to distinguish privilege levels, right? And we'll discuss this very, very soon. So distinguish between kernel mode and user mode. Okay? Use system calls, appropriate system calls as a gateway, right? To facilitate access to files, right? So reading, writing to files, for instance, deletion of files. To check permissions on every access. So every time I want to open a file, I go here and I double click on a file. Implicitly behind the scenes, what the operating system will do is to check if I, as a current logged on user, has access to read that file. Every time I want to write, to check, do I have access to write to that file? Okay. Associate user IDs and groups, right, with processes. Is it? Processes. Each of these processes is associated with a user, right? UID is user ID here. Is a user, right? Sorry about that. Is a user. Each process is associated with a user, ideally, right? And a group. Each user is associated with a group as well. It's a nice way of coming up with fine-grained permissions. Some permissions can cascade across groups. So you're saying everybody who's part of pseudo group can do ABCD. Everybody who's part of administrator group can do ABCD. Okay. What else? To provide auditing, right? So you can actually access logs, right? Is it on the computer or something? You have access to logs. In this particular case, I guess. What else? What can I do here? If I change directory here, I can check auth logs, I think. Right? I can have a sense of what exactly is happening here, right? Who is doing what? A classic example of an audit log. Again, this is usually quite useful on server computer systems, right? Pause here and think. The piece of computer, right, that is used to host the student information system. This thing you call SIS, right? You go to sis.unza.dem and all that garbage. Then you go here, right? This piece of software is sitting on a server computer system. That's a very sensitive piece of hardware. Why is it sensitive? This is where you have user records, results of users. They've actually been reportedly, allegedly, cases where people have changed grades. So what you can do is you have people like security experts who are part of SIS that will regularly check these logs, right? At the OS level, but also at the application level, right? Audit logs to see if anything off happened, right? As part of the investigation. So it is the role of the operating system to provide auditing, actually, right? In essence, information outlining who did what and when, right? So if you look at these auth logs I was checking here, who did what and when, including the exact timestamp, right? Who did what and when, right? When? What did they do? Anyways, so why do we need this protection and security? Well, it turns out without protection, a malicious program, for instance, can easily read password data, right? Or can essentially be designed in such a way that it can crash the entire system. You've heard of what has reportedly happened with entities like NAPSA, right? I don't know if you remember that. Anyway, okay, so we're going to pause for now. I'm looking at the time. I need to transition to a different direction, but just to give us an idea, what we're doing next is we are going to set the stage for looking at the kind of next topic of discussion. And what I've done, right, in this particular, maybe I should decouple these. What I've done is I've combined, I think I did mention that we're going to take a top-down approach, right, where we are looking at generic features of the operating system, and then we're going to go into detail to look at what, you know, Ubuntu and all these different operating systems are all about, and Windows and stuff like that. In fact, it's the reason why I'm going to share this later on here, but why I have these ISOs here, right? For Ubuntu, this is Windows Server as well. We're going to look at, we're going to start off with the case studies, and then we'll start looking at the these core functions that we're discussing. So then zero down to process management, memory management, IO management, and security, right? So we're taking a top-down approach ideally, rather than doing these case studies towards the end. We'll first of all look at them at the very beginning, so that when we start discussing these things, they will make sense or something. Okay, I don't know if there are any thoughts or questions about this. I'm thinking, should I remove this and put it in a different slide, but we can leave it. I don't know if there are any questions that people have. Can't see any hands up. Okay. Yeah, but Google Meet is consuming a lot of data. What you can do is, they've taught you this. You're in second year now, right? You should take a step further, and you'll be like, what can I do to reduce data usage on Google Meet, right? You go to settings, is it? Right there on your Google Meet. You go to settings, then you can change the resolution, right? So that what is sent, what you're receiving on your end here, you go to settings, you go to video, right? And then under receive resolution, just change this, right? Instead of auto, you can just go to standard, right? You understand? So if you go to, it's like 360p or something, which will usually generate very little data. You understand? You want to, you know, beginning second year, you want to take the initiative and start looking into, you do a little bit of research or something like that. Okay, that's fine. I see there are no questions, no hands up. I'm taking attendance in this course, by the way. I take attendance, and I want to incorporate them into final course score here. Clearly, people are not taking this seriously. That's on you. Okay, I'll leave it at that. I'll see you when you see me, which is tomorrow. I do take attendance, right? Before people leave here, I just want to tell you here. I've told you before, but I'm going to do this again. I take attendance. So right now, I have taken note of the fact that only the following have attended class. That's on you. Like right now, only these people have attended class. And I literally can see even how much time you've attended. So if you think you're going to come towards the end here, like you come to attend class at 8:48 when we're supposed to wrap up here. I don't know how this, okay, I don't know how this is going to be here, right? So I take attendance, right? Just take note. You know, I take note of not just people showing up, but like how long have they spent in class? This is a 2-hour long, this is a double session. Okay, but if you want to lose marks, that's on you. Thank you very much. Till we meet again, which is tomorrow. Good day. Bye. Ubuntu. I want to discuss that in, I think, in the next lecture series, but it depends. The answer is it depends on the use case, right? So it is okay. It will work just fine, right? Thanks.